Okay, so I thought I'd just do a bit of a demo of the high-Z, high-Q, capacitively loaded vertical ground plane antenna. Bit of a mouthful. So at the moment I'm running it on 40 meters. Now the system at the moment, its remote tuner that's up at the antenna can bring it in between 160 and 80 meters. So to bring it on 40, I need an additional tuner at this end. So I've got a manual magnetic tuner set up. This is the control unit for the remote tuner. So it's basically a DC supply and a bias T. So I can turn a motor up at the antenna that turns a magnet and adjusts the inductance of my high Q step-up transformer. So I'm on the IC705 here, and it's running 100% power, which is 10 watts. So at the moment, I'll jump around Australia and show you how it's doing at the moment. It's very low TOA, so in this video we'll just be doing 40 meters. So this is into the Hunter Valley in VK2, New South Wales. And you can see this is my trace here. There's someone doing a comparison beside me there, that's fine. And so looking at the signal, it's very close to an S7. Sometimes it's been edging over the S7. Yeah, there you go. So doing quite nicely there. Very solid actually, into the Hunter Valley in New South Wales. Right. Now what I'll do, I'll quickly jump into the Space Weather Service's hourly HAP chart and I'll update that. And for those that aren't familiar with it, I'll just give a very brief explanation. So you center it on your location, and so I'll just get the mouse going again. So I'm down here in the yellow blob, okay? And what it does, unlike the ionospheric map that tells you that's color coded in what frequencies will come back down, which is near vertical incidence skywave, NVIS, what this does is calculates what distance you're likely to get on each band in the current conditions. So, and as you can see, there's the color coding here. So the yellow blob is, my eyes are very bad today, 4 megahertz, and the brown is 6, the dark green is 8, the light green is 10 megahertz, the light blue is 12 megahertz, and so all the way up to 10 meters, okay? So from my location to the Hunter Valley, which would be somewhere there, it's in the correct range for 40 meters, okay? And so is this for VK5 when I check there. If I'm lucky enough to get into West Australian SDR, then at the moment the conditions, 18 megahertz would be more suitable up there, not 7, okay, across there. So that gives you the idea of the current conditions. So I'll quickly jump in now, and I'll leave the Hunter Valley. I'll zoom out to show you Australia. Right, so the Hunter Valley was up there, okay, and I'm down here. So I'll try get into Western Australia first. Hopefully I can get in. It's a very popular SDR. And, no, alright, I'll try that one in a few moments. So what I'll do next is I will jump up to VK5 in South Australia. So I'm down here. I'll jump up here and see if I can get into this one. Lucky. And see how it's doing into VK5. So it looks like about an S6 at the moment into VK5. Okay, and now I will jump out of there and I'll go a bit closer to my location in Ararat, central western Victoria. And depending on the time of day, sometimes this is too close to me. It might be okay at the moment, it might be terrible. There you go, too close. Nothing. I'm not even audible in Ararat. Okay. Now I would need more NVIS angles to be coming in good there in these conditions. So I'll zoom out again so you can see Australia. I'll now move up here to the Australian Capital Territory. Hopefully I can get in there and we'll see how it's doing in that location. Oops. And yeah, scarcely perceivable in Australian Capital Territory. Okay, now I'll move up here, I'll zoom in a bit, up into New South Wales. If I can get into this one, this is in the Hunter Valley in VK2, New South Wales. So we're getting quite a way away now. And hopefully it's coming through good. Oh yeah, have a look at that. So a good solid S7. As soon as I say it, it drops, but nearly an S7. There you go. So she's doing nice and solid up there into VK2. Yeah, beautiful. Beautiful. Now it also has the same type of takeoff angle for 80 meters, okay, which I'll demonstrate in another video. It's the nature of the design of the system. I'm coming at it from a different approach. So the working principle is about having the highest potential voltages between the vertical part of the vertical element and the radials, and that's why it's high Z. Actually, I'll just sidetrack for us a moment. Because I'm running 40 meters, I think I mentioned that I can tune 160 and 80 at the antenna, but I need tuning at this end as well for 40 at the moment. What I'm doing is I'm probing the output that goes to the antenna, and of course at the antenna that variable transformer is a step-up transformer, but I'm looking at the voltages at this end. This is how I've been tuning it with the mag tuner at this end. So you can see it's peaking at about 112 volt peak to peak at this end. Of course, when it goes through the step-up transformer into the antenna and then to the very end of the elements, it's a capacitively loaded system, the peak-to-peak voltages will be way in excess of 112 volt peak-to-peak. And you can see the RMS there, hopefully you can see that's about, I'm having trouble, 39 point something, let's say. So there you go. So that's the Hunter Valley, doing very, very nicely indeed. Now I'll zoom out. That's the wrong way, Pop. Brisbane up there, it's a very in Queensland. That's a very noisy SDR. So generally for me, if I can pick it up there at all, that's just a good sign. But it's probably not impressive. Though last night, actually, at a certain point, it was favouring that and doing very well. So let's see. All right. So S3, S4 up into Brisbane. Oh, picking up nearly an S5 there for a moment. Yeah, there you go. Give it a moment. Alright, I'll jump out of there since it's failing on me. And now I'll try to get out into the Wild West. Come on, Western Australia, please let me in. Wouldn't that be nice? It's often a tough one to get into. Okay, we're in. Let's see, how are we doing out into the Wild West? So S6 there. I think it'll hit the S7. I have a feeling we've got QSB. she's dropping even more. Yeah, she's not quite hitting the S7 now. Yeah, sometimes it's hammering over the S7 into Western Australia, but it's just one of those things, as you know, with HF. Right, and now I will jump out of Western Australia. Just out of curiosity, I'll go to my own neighbourhood. Now, I'm just up in the eastern hills of Melbourne. I'll try and show this on here. So, let me have a look. Let me see. So, let me see. Where is it? Yeah. So, there's that little reservoir there, and I'm somewhere in this area. Yeah, Emerald, right there. Okay. So I'm there. There's a mountain range. So there's a mountain called Mount Dandenong here, which is very high. So I'm sort of blocked off from Croydon, which is where this SDR is, but it is close. But I need good NVIS angles to get this one well. So as you can see, although I'm very, very close, it's scarcely perceivable in Croydon. So that just shows the fact that it has such a low TOA. And now, let's see, I'll just jump back up to the Hunter Valley, see how it's going up there. If I can get in, yep, beautiful. So a good S7 by the looks of it. Yeah, nice S7 up to the Hunter. So there you go. So she's doing very, very nicely. Now what I'll do is I'll just make an adjustment. I'll turn on the DC and basically rotate the motor up at the antenna. And what you'll see is the waveform and the voltages change as I do that. So we're about 112 volt peak to peak. I'll start turning the magnet up at the tuner, and you can see I've now detuned. So about 37 volts peak to peak, and this should actually start to show a bit of a drop. Yeah, so the signal now is S4, S5. Oh, conditions are still pretty good. And now I'll turn the controller and try and tune myself back up to peak. That's 105. I might have passed it, so I'll just go around again. I need a reverse option. $101. I'd be better doing this with a steady carrier, of course. 105, 6. I want to get it back to about 112. So I'm trying to go in baby steps. It looks like I passed it. Okay, I'll just try my luck again. But for now, I'll leave it there at 108. That'll do for the sake of the video. And you'll see she's come back up quite nicely. Very close to an S7. Oh, I've got someone running a comparison next to my trace there. I get that a lot, that's fine. And this is the experimental capacitively loaded remote tunable vertical ground plane on 80 meters now into VK5. This is my trace, and this is the Dural beacon, VK2 Whiskey India, 35 watts, half wave, 80 meter dipole, 10 meters elevated, and 10 watts on my experiment. So we got what looks like a good solid S7, let's see. Oh, it's just dropped under as I say it. It's always the way. Oh yeah, so up to an S7 there. And I'll just jump up to Dural from VK2. And as you can see, it was over the S7. So it's just a bit under at the moment. Yeah, see, just over the S7. Alright, and I'll jump back to mine. And now she's dropped to like an S... what is it, let's see. I'd say S6. So that's to be expected. Like if I was running a half wave 80 meter dipole at 10 meters elevation, you know, if all things were equal, for example, then I would have to multiply my 10 watts 4 times to increase by 1 dB. Sorry, 1 S point. 1 S point, not 1 dB. 1 S point. So basically, this infers to me that my experimental antenna is equivalent in a way, of course different, but equivalent to a full-size half-wave 80 meter dipole. But it certainly doesn't take up the same amount of space. It's not small, but it's not as big as an 80 meter dipole or a quarter wave 80 meter vertical ground plane. So that's actually very, very impressive for the 80 meter band. And this is just a quick demo of the magnetic tuning system, the remote operated magnetic tuning system. So on the VNA I'm looking from 1 megahertz to 4 megahertz. I've got my pointer set at around about 3.6. What is that exactly? Let's have a look. 3.580 megahertz. So let me see. So you can see the SWR up there at the moment, 2.1, okay, to 1. That's pretty high. And what I'm going to do is I'm going to operate the magnetic tuner, and you can watch how it sweeps through the tune across that part of the spectrum. And one thing I'll point out is it's not as simple as sweeping along and back. It has at least 3 different sweeps. So I will now start the rotation of, oops, forgive my, that was a bad connection there. I'll start the, I've got to get new connectors for this VNA. Alright, I'll start the rotation of the magnetic tuner slowly and just let it go, okay? That's one of its sweeps. It's a different sweep and then a different sweep, see? So it's not quite as simple as just sweeping back and forth. So if you miss a point, you may well get it on the next run even better. So I'll slow this down. Hang on. Oh, I'm going the wrong way. Am I? Alright, there's super fast. Is it? No, that's... I'm getting dyslexic. That's super slow. So I'll speed it up a little. Slow it down. Stop. We're about 1.2 something. I'll speed it up. Forgive those bad connections. There's nothing much I can do about that right now. So you get the idea. Now what I'll do very, very quickly is I'll take the frequency down. I'm having trouble seeing. That's my biggest problem. Let's say I want to go to around about 1.8. That'll do. Megahertz. Now I'll try and bring it in at that frequency. Sorry about these bad connections. I've ordered some new adapters and shit, but they're not here yet. So I've got to get it in at 1.8. So that's showing me, what, about a 1.4 in that position. I'll get it moving again. And I brought it down, but I've gone past that now. Alright, and we'll try the next sweep. Is that a 1 point? Hang on, I'm so sorry about my bad vision. 1.2 something to 1, but you get the idea. Now, of course, the outcome here, as I do these sweeps, depends a lot, of course, on the actual antenna itself. So I can change the element lengths, the relationship between the elements, and this will all change. But this is the basic idea of the mag tuner, okay, and being DC remote operated. Okay, now as you can see, it's swinging up and down but not going to 40. That's why I had to use an additional tuner on 40, but I may well just add an element for 40. 7.3.